We are told that each row has one extra seat compared to the row before it. Row 1 has 28 seats, row 2 has 28 plus 1, which is 29 seats, and row 3 has 29 plus 1, which is 30 seats. To find the number of seats in row 10, we can just continue this pattern all the way down. Row 4 will have 31 seats, row 5 has 32 seats, row 6 has 33, row 7 has 34, row 8 has 35, row 9 has 36, and row 10 has 37. So our answer here is that row 10 has 37 seats. To solve this question, we should try to spot the relationship between the row number and the number of seats. Row 1 has 28 seats. Since we need to add 27 to get from 1 to 28, the number of seats is 27 bigger than the row number. Row 2 has 29 seats. Again, the number of seats is 27 bigger than the row number. The same thing happens for row 3. 3 plus 27 gives us 30, and the same pattern will follow for all the other rows, because each time we increase the row number by 1, we're also increasing the number of seats by 1. So the pattern is that the number of seats is 27 bigger than the row number. We can write this in an equation by saying that seats is equal to row number plus 27. We are told that there's 50 seats in the last row, so we want to find the row number which leads to 50 seats. We can do this by replacing seats by 50 in our equation. So we know that 50 is equal to row number plus 27. To find our row number, all we have to do is subtract 27 from both sides. When we perform the calculation, we find that the row number is equal to 23. So we found that the row number of the last row is 23, therefore there are 23 rows of seats in our theatre. In parts A and B we found the following. Row 1 had 28 seats, row 2 had 29 seats, and row 3 had 30 seats. This pattern continued all the way until the final row, row 23, which had 50 seats. To find the total number of seats, all we'd have to do is add up all these individual values. One way to do this would be to use brute force by getting out our calculator and adding up all these numbers. 28 plus 29 plus 30 plus 31 plus 32, all the way up to 50. However, there's another cleaner approach which uses the result for the sum of an arithmetic sequence. This can be found in the formula book on page 20. It says that for an arithmetic sequence with first term a and common difference d, the sum of the first n terms is given by s of n is equal to n over 2 times 2a plus n minus 1d. If we can find the values of a, d, and n for our sequence, we can use this formula to find our answer. A refers to the first term. In our sequence, the first term is 28, so a is equal to 28. D is the common difference, and this refers to the change needed to get from one term to the next. In our sequence, this change is plus 1, so our common difference is d is equal to 1. Finally, n refers to the number of terms we want to add up. We want to add the values for the first 23 rows, so we have n is equal to 23. So let's take our formula and sub in these values of a, d and n. 2 times 28 simplifies to 56, and 23 minus 1 times 1 gives us 22. 56 plus 22 is 78, and when we multiply this by 23 over 2, we get our final answer of 897. In part C, we use the sum of an arithmetic sequence formula to find the number of seats in the first 23 rows. To do this, we subbed in the values a equals to 28, d equals to 1, and n equals to 23 into our formula. If we want a general expression for the number of people the first n rows will seat, we can put in our a equals to 28 and d equal to 1, but leave the n as it is. 2 times 28 is 56, and n minus 1 times 1 is just n minus 1. 56 minus 1 is 55, so our expression we get is n over 2 times 55 plus n. So, given any value of n we like, we can sub it into this formula and will tell us how many people the first n rows will seat. This lends itself nicely to the trial and improvement method. Here, we'll make a series of educated guesses until we find the correct answer. We need to find the number of rows to seat 600 people, so we can sub in different values of n until we get close to this target of 600. As a first guess, I'll try n equal to 20. Subbing this into our formula gives us 20 over 2 times 55 plus 20. When we type this in our calculator, we get an answer of 750. This means that the first 20 rows would seat 750 people. We only wanted to sit 600 people, so this number is too high. So for the next guess, it would make sense to try a smaller value of n. Here, I'll try n equal to 15. Subbing this into our formula gives us 15 over 2 times 55 plus 15. Calculating this gives an answer of 525. So we know that the first 15 rows will sit 525 people. Remember, the target is 600 people, so this time we've come out too low. The first 15 rows wouldn't have enough seats for all 600 people. Since this guess was too low, we should try a bigger value of n for our next guess. Let's try n equal to 17. When we sub in and perform the calculation, we get out 612. The target is 600, so our answer here was too high. So we should try a smaller n value for the next guess. Let's try n equal to 16. Subbing in and using our calculator, we get 568. This is lower than the target of 600. We found something interesting here. The first 17 rows would sit 612 people. So the 600 people we have would not be enough to fill these. However, the first 16 rows only contain 568 seats. So the 600 people is enough to fill the first 16 rows. One way to think of this is that with 600 people, we will fill the first 16 rows, but not the 17th. So the value of n we were asked to find is 16. We were also asked to find the number of people who would be seated in the next row. Well, the first 16 rows would sit at 568 people, so we'll have 600 minus 568 is equal to 32 people spilling into the next row. To find our total income, we'll need to consider the money we make from selling our adult tickets and the money we make from our children's tickets. Let's start with the adults. Each ticket costs €25, and we sold 276 adult tickets. To find the income here, we simply multiply these numbers together. €25 times 276. This gives us €6,900. For the children, each ticket costs €12. We sold 212 children's tickets, and to find the income from these tickets, we multiply these numbers together. €12 times 212. This gives us €2,544. To find our total income, we'll add together the income from the adult tickets to the income from the children's tickets. This gives us €9,444. The ratio of adult tickets to children's tickets is 3:1. So for some unit, we'll have 3 units for the adult tickets and 1 unit for the children's tickets. We know that the total tickets sold were 752. The total number of units we have here is 3 plus 1, which is 4. The total units must correspond to the total number of tickets, so we'll have 4 units equal to 752. To find what 1 unit is, we can divide both sides by 4. Performing the calculation here tells us that 1 unit is equal to 188. This immediately tells us that the 1 unit we had for the child tickets is equal to 188. For the adult tickets, we had 3 units. If 1 unit is 188, then 3 units will be 188 times 3. This gives us 564 for the adult tickets. So our final answer is we 564 adult tickets sold and 188 child tickets sold. In part FI, we found that there was 564 adult tickets sold and 188 child tickets sold. This information will be crucial when we're tackling this question. We're asked to find the cost of a children's ticket for the show, so let's let X be this unknown value, the price of a child's ticket. We know that an adult ticket costs 2.5 times as much as a children's ticket. So if X is the price of a child's ticket, the price of an adult's ticket will be 2.5 times X. The only other bit of information we're given is that the total income was $17,578. This income will compose of the income from the adult tickets as well as the income from the children's tickets. Let's think about both of these in terms of X. The income from the adults will be the price of an adult ticket times the number of adult tickets. The price of an adult ticket is 2.5x, and the number of adult tickets is 564. Since 2.5 times 564 is 1,410, this comes out as 1,410x. The income from the children will be the price of a child's ticket times the number of child's tickets. The price of a child's ticket is X, and the number of children's tickets is 188. So this comes to 188X. To find our total income, we should add together the income from the adults and the income from the children. So we get 1410X plus 188X, and this gives us 1598X for our total income. But remember, we know what the total income is. It's 17,578. We can equate these two expressions to get 1598X equal to 17,578. To find the value of X, we just need to divide both sides by 1598. Performing the calculation on the right-hand side gives us an answer of 11. This means that X, the price of a child's ticket, is €11.